Hi guys. In this video, we're going to talk about derivatives and product rules, but this is day 2. It's the same thing we did yesterday, but on steroids. So now notice that I'm going to need a product rule here, and I'm going to need a product rule here. So just because we're here, I'm going to label my functions 4 different letters. So this is going to be function f, function g, function a, function b. You can call whatever names you want. You can even number them. It doesn't matter to me. Okay. The derivative of f is 2x. The derivative of g is cosine of x. The derivative of a is 3x squared. And the derivative of tangent is secant squared of x. I want to highlight this minus right here in the middle. That's not your friend. That's what usually gets everybody right there. Okay, so we will apply the product rule, and just a little reminder right here. It's f prime g plus fg prime. So f prime g. So f prime is 2x. 2x times g plus fg prime. So f g prime. So f is x squared. G prime is cosine of x minus. Now just open a bracket here just to make sure that I will remember to distribute that negative right there. So here we go. A prime b, so this times this. So a prime is 3x squared times b, b's tangent of x, plus a b prime. A is x cubed, b prime is secant squared of x. All right, we will leave everything in terms of sine cosine. So first I will deal with that minus. And then let's go ahead and rewrite tangent and rewrite secant in terms of sine and cosine. So tangent is sine of x over cosine of x. And I know secant squared is 1 over cosine squared of x. Okay, now I will pull out, what do they all have in common here? I will factor it out. I can pull out x, and that's about all I can do. So we will factor it out. So I have 2 sine of x left over from this guy. I will have x cosine of x from this guy minus 3x sine of x over cosine of x minus x squared over cosine squared of x. Okay, what else can I do here? This looks fine because it's already in terms of sine and cosine, but it's just not pretty. Let's go ahead and rewrite this as common denominator as cosine squared. So if I make everybody with the common denominator of cosine squared, that means I need to multiply this one and also this one by cosine squared, and this one just by cosine. So off we go. So 2 sine of x cosine squared of x, because I multiplied that by the common denominator to make that even out, I guess. So x cosine cubed of x minus 3x sine x multiplied by cosine, just one cosine, not cosine squared, because I already have a cosine here. So just cosine, and then this one I don't have to do anything because it's already over the regular denominator or the common denominator, so minus x squared. Now, from my beautiful double angle identity, I know if I have 2 sine of x cosine of x, I can just rewrite as sine of 2x. And I have that right there because I know cosine squared is just cosine times cosine. So I can rewrite, we're almost done, this, not with the squared, but I can rewrite as sine of 2x, and then I have a cosine left over here, cosine of x. And then there's nothing I can do to anybody else over here for me to rewrite, so everything will stay the same. And everything over the common denominator of cosine squared of x. So this one is fully simplified, even though this one is already in terms of sine and cosine. But this we're kind of little just showing off right there with the double angle identity.